few points to think about. Okay. Real life application. When am I going to use this? Probably never, but I'm going to show you. If you ever take physics in college, or or you're driving an airplane and the wind is blowing and you got to figure out what's going to happen, someone has to program those computers, right? Maybe that's you. This is kind of important as we get to story problems. The velocity of a moving object is a vector because velocity has both magnitude and direction. If you take the magnitude of a velocity vector, it will be the speed. Right? That's kind of cool. So when they ask you to find the speed of something and they give you the velocity, you just have to find the length of that vector. So that's kind of something. I was doing these problems yesterday, and I was like, well, how do they know to do that? And then I found this in the book, and I said, oh, look what happens when I read. I learned. All right. I thought we'd start by just re-emphasizing where we ended yesterday, because it was pride time, and I rushed through that, and I made you stay after the bell. But if they give you a vector, I like your book says, you may recall from our applications in section 4.8, I'm sure y'all remember that, right? That direction is measured in different ways in different contexts, especially in navigation. So think about sometimes, remember we've done problems where they're like, Ranger Rick sights the fire 30 degrees west of north, right? We don't usually talk about directions like that, but that's one way to talk about direction. So direction can be talked about in different ways, especially in navigation. And so a simple but precise way to specify the direction of a vector is to state its direction angle, theta, which is the angle that it makes with the x-axis. Using trig, we can see that the horizontal component and the vertical component are these values. And so that's where this comes from. The horizontal component for this vector is that v1, and the vertical component is what we said is v2. And so when we talk about finding those components, I think it's helpful today as we talk about giving the velocity of an airplane. What does it mean when we find the component form of that? What is that saying? And so I just wanted to make sure we kind of understood that before we moved on. All right? The tricky part about this is they never give you theta. They always measure it from somewhere else. Like they measure it from north, or they measure it from somewhere, and so then you have to figure out what theta is. I found that to be the hardest part of doing these problems, because I could do the trig, I could do this part, but I had trouble getting to the correct angle. So I thought maybe this could help you, which is also in your book. I fucking did. But here we go. Look at this lovely picture here. A DC-10 jet aircraft is flying on a bearing of 65 degrees at 500 miles per hour. Find the component form of the velocity of the airplane. Recall that the bearing is the angle that the line of travel makes with due north, measured clockwise. So that's important, because all the problems today seem to talk about flying on a bearing of whatever. So they did this one for us, but the next one's not done for us. So if they give us the bearing of 65 degrees, that means like 65 degrees measured from north in a clockwise direction. So the angle that we want is the angle that it makes with the x-axis. So we just take 90 minus 65 to get 25. Right? That's not so bad. A little bit trickier when it's more than 90 degrees, and you have to think about where it would be. They give us the velocity at 500 miles per hour. So we want to find the component form of that. That's just the formula I just gave you. The component form is the magnitude times the cosine of theta, and the magnitude times the sine of theta. This is probably going to be your favorite kind of story problem, because there's not so much to do, and they gave you a picture. But we're not going to use 65 degrees, we're going to do 25 degrees, and we're just going to use 500 as our magnitude, all right? Like it's 500 miles per hour. So we're going to just say 500 cosine of 25 degrees, 500 sine of 25 degrees. And again, using a calculator is how we're going to get our decimal answers here. Let me get mine out to make sure I get the same answer that I got there. Something, I don't know if you noticed this yesterday when you did the problems, but if you're in quadrant 1, your component should be positive, right? Because you're in quadrant 1. But if you're in quadrant 2, right, your first component's going to be negative because you're on the negative part of the x-axis. Your second component should be positive. If you're in quadrant 3, both are going to be negative. So that's kind of a nice way to check to see if you did this correctly and if the signs match up at least. So I got that to be 453.15 and 211.31. So what does that mean? The components of the velocity give the eastward and northward speeds, like the horizontal and the vertical distance. So that's saying that this airplane is traveling 453-ish miles per hour eastward and 211 miles per hour northward as it travels on the bearing of 65 degrees at 500 miles per hour. So it's just giving you like a horizontal and a vertical velocity there. I don't know. I'm not a physics gal, so this isn't my favorite stuff. That's it. That's not bad. All right, you ready for the bad one? I only have one other example. That should tell you it's kind of rough, right? And I even put the homework way down at the bottom of the next slide because you're probably, look, this is all my work. But only one of this has this. Like 4 of them are multiple choice or something. An airplane is flying on a compass heading bearing of 170 degrees at 460 miles per hour. A wind is blowing with the bearing 200 degrees at 80 miles per hour. Part A is what we just did on the last problem. Find the component form of the velocity of the airplane. Part B, find the actual ground speed and the direction of the airplane. Because the direction of the airplane is going to be different than 170 degrees because the wind is going to affect that. All right? So, let's draw a picture. I'm not going to draw an airplane. I'm just going to draw a line. So if we're going from north, we're measuring from north in a clockwise rotation. Starting here, I want to go 170 degrees.
I feel like the plane's crashing.
Why? It's just heading south, right? If this is north, this is south. So if I measured from here all the way to here, that would be 180 degrees, right? So if I measured from here to almost here, I could say from here to here is 170 degrees. You follow me on that? But I don't want 170 degrees because the angle that we use in component form is just measured from the x-axis. So could you tell me what the angle would be just from here to here? Negative 80 degrees. Do you agree with that? Because I'm below the x-axis. I actually did 280 degrees because I just said 360 minus 80, which is just the positive of that. It's the same thing, right? So it doesn't matter if you say negative 80 or that would be the same as positive 280 because that would be like measuring from here this way. No? Follow me on that?
Yeah.
So the book did negative 80, so I'll stick with it, I guess. So that's an important part. You have to figure out what the angle is. The magnitude we already know because they tell us it's 460 miles per hour. So if you can figure the angle out to do part A, all we have to do to find the component form of our vector is take 460 times the cosine of negative 80 and 460 times the sine of negative 80. And again, calculator. Anybody want a calculator? Make sure you're in degree mode. We've been doing a lot of radian stuff, but these always are in degrees. It's not going to be pretty. $79.88. Did you get that? And then like negative 400 again, I can at least check that my signs are right. In quadrant 4, does it make sense that the first component is positive and the second component is negative? So that's a nice thing to check. Okay, that's part A. Part B, I want to find the actual ground speed and the direction of the airplane. That means taking into consideration the wind. So, first of all, I think we need to figure out the component form of the wind vector and then talk about what we would do with those. So, if the wind is blowing with a bearing of 200 degrees, I'm going to change colors here. I'll call this V for that one. 200 degrees measured from here. 180, 200 would be somewhere-ish over here, right? Brady says that's negative 110. Do you agree with him? It's how many more degrees than, 30 more degrees than that, right? So 30 plus 80, 110, but we're still going, if we're measuring from here to here, that would be negative 110. Or again, you could measure positively. And again, I'm a positive kind of gal. So I did 250, but it's the same as negative 110. So it doesn't matter. So I called this W for wind. And the wind is 80 miles per hour, a bearing 200 degrees, but we're going to use the actual angle from 0. So we're going to just say that's 200 times cosine of negative 110 and 200 times sine of negative 110. And again, it just becomes a calculator issue. If I'm over there in quadrant 3, I should get 2 negative components, yes? Did I do something wrong? Why did I use 200? You're right, sorry. Thank you. I'm supposed to use the magnitude. Look, I underlined 80 and then I wrote 200. Thank you. I got negative 27.36 and negative 75.18.
That it?
No, that's just the way. I want to find the actual ground speed and the direction of the airplane. So the direction of the airplane we're going to have to trig at some point. The actual ground speed means I need to take into consideration what happens with the airplane and the wind at the same time. So what do you think that means I'm going to do with those two vectors if I want to think about?
Add them.
I'm just going to add them together. I'm going to add the velocity of the airplane vector, and I'm going to add that to the wind vector component form, and that's going to tell me kind of where the what's happening with the airplane. So I'm not going to actually draw this in, but basically I'm going to add these two together and think about what we talked about yesterday, that would end up, it should end up somewhere out in here, right? If I did that lovely little parallelogram thing and add it up, but I don't need to do that. I'm just going to add it together. V plus W, and I just add those and add those on my calculator. That's going to give me the vector of where the plane, or the velocity. I got, let's see if you got what I got. 52.52 and negative 528.19. Did you get that?
Is that the air?
Is that speed?
No.
No. What did we say? What was my first slide? What did we say we could, what speed is compared to a velocity vector?
Magnitude velocity.
It's the magnitude. So we had to find, putting the airplane and the wind together, like what's happening. To find the speed, we need to find the magnitude of this. How do you find the magnitude if you have a component vector? Or vector form.
Yeah, what is it?
Yeah, I'm just going to take the square root of squaring the components, right? So I'm going to take the square root of 52.52 squared plus, I'm just going to write 528.19 squared because it's going to be positive anyway. That's going to give me speed. Speed is a number. I got 530.79 miles per hour. So we did part A. We found the speed. Yes? What else do we need to find? The direction of the airplane. So the direction, or what angle, is V plus W going in. And so that's where I just use the component form. And I'm not, I don't know if we want to draw it out or not. But, I don't really want to label that. But, what quadrant would that have to be in if it's 52.52 and negative 528.19? That means it's over here somewhere, right? I'm just going to draw in a very terrible graph and label it not to scale. Do I know the vertical and the horizontal components of this?
Yes.
Yeah, this is V plus W. I'm looking for theta. If I know this is my first component, I don't even know what, I'm just going to label this second component, I mean, right? My 528.19, and this is like 52.52. Can I set up a trig equation to solve for theta?
Yeah.
Tangent. And it always will be tangent, because if you know the vertical and the horizontal component, it makes sense that you would use tangent to set that up, so you don't have to draw the picture every time. But I wanted to just to show you that we could say tangent would equal negative 528.19 over 52.52. And how would I solve that for theta? Inverse tangent on my calculator. And I got negative 84.32 degrees. With me to there?
How are we done?
Except, how do we give direction when we're talking about airplane flight? Do they want the negative 84 degrees, or do they want the bearing? My bearing. And so this was the part that I was struggling with yesterday, which is really not that bad to think about. If this is negative 84, that means I know from here to here is 84.32 degrees, right? But I want to measure it from here, so I need another 90 degrees. Does that make sense? Do I need this to be negative if I'm measuring from north? Does it make sense that I'm just going to take 90 plus that? I was struggling because I was trying to keep it negative, and I was like, why is this not working? But basically, I'm just going to take my answer and add 90 to it, and that would give me the bearing angle. And I believe that's the answer they give you in the book. So the bearing would be 174.32 degrees, and the speed would be 530.79. Not saying that's the easiest question in the whole world, but I gave you one on your homework that's very similar, like just the numbers changed. So you should be able to follow this example and do the same idea. To me, the angles are the hardest thing for me because I had to think about going from 90 and I was trying to come up with a lovely formula. But really, I think just drawing the picture is the easiest thing to do on that. That's what I did when I did it. 45 is the one that's like this, which means it's odd, so you can check your answer. There should be work to go with that, right? Like you shouldn't just be able to magically say you got the answer. 42 and 43 are like our first example, where they just give you whatever and they ask you to find the component form, so that's not that bad to do. 45 is like the one we just did. 57 through 60 are multiple choice, kind of just re-emphasizing what we did yesterday, like which one of these is in component form, which one of these is the magnitude of this. Pretty simple, like 57 through 60, you could get done in like 2 minutes probably. But start with these, because those are probably the ones that you have questions on. But very similar to our notes, so those will probably be the ones that we look at. If you're going to take physics someday, or you're in physics now, you take physics in college, just stuff will come into play. There's a lot more stuff you can do with velocity or with vectors like force. Like there's always the question like a box is sliding down a ramp and you can figure out like what the force is or how much the box weighs if you know the force and doing all these vector stuff with that. So we'll see how it goes.